Imagine holding a creature that lived 500 million years ago, or walking in the actual footprints of a dinosaur. Thanks to fossils, we can do exactly that. These amazing time capsules preserve the history of life here on Earth in incredible detail. Welcome to Sciesmic. I'm Matt, and today we're going on a journey through deep time to explore fossils and the fossil record. By the end of this video, you'll understand how these ancient treasures form, what they tell us about evolution and extinction, and why paleontologists get so excited about rocks that contain the remains of long dead creatures. Let's dig into Earth's greatest mystery story. Let's start with the big question. How do fossils form? It's actually an incredibly rare process that requires just the right conditions at just the right time. First, an organism has to die in the right place. Usually this means somewhere it can be buried really quickly, like near a river, a lake, or an ocean. Fast burial is crucial because it protects the remains from scavengers, bacteria, and weathering. Next, sediments like mud, sand, or silt pile up over the remains layer after layer. Over thousands and millions of years, these sediments get compressed and turn into sedimentary rock, and that's where most fossils are found. Now here's where it gets really cool. As the organism is buried, minerals and groundwater slowly replace the organic material, atom by atom. It's like nature's 3D printing, creating a stone copy of the original creature that can last for millions of years. But here's the catch. Fossilization is incredibly rare. Scientists estimate that less than 1% of all organisms that ever lived actually became fossils. Most creatures decay completely or get destroyed before they can even fossilize. That's why we have tons of fossils of shells, bones, and teeth, hard parts that really resist decay, but very few fossils of soft tissue like skin, muscles, or other internal organs. Now, not all fossils are the same. There are several different types, each preserving different information about ancient life. Body fossils are the most common one that we think of. Actual parts of organisms like bones, shells, teeth, or leaves. These show us what ancient creatures looked like and how they were built. But trace fossils might be even more exciting. These preserve evidence of ancient behavior, footprints showing how dinosaurs walked, burrows revealing where ancient worms lived, or even fossilized poop called coprolites that tell us what ancient animals ate. Sometimes we get incredibly lucky with exceptional preservation. Insects trapped in amber are perfectly preserved for millions of years. Frozen mammoths in permafrost still have hair and skin intact. Petrified wood forms when minerals completely replace the original wood, creating beautiful stone trees. Molds and casts form when an organism decays completely but leaves a perfect impression in the rock. Some of the most beautiful fossils are compression fossils, where organisms are flattened in fine sediments but preserve incredible detail. We can even see the veins in ancient leaves or the patterns on an insect's wings. Here's where fossils really become time machines. The rocks that contain fossils are arranged in layers, and these layers tell us about Earth's history in chronological order. It works on a simple principle called superposition. In undisturbed rock layers, older rocks are on the bottom, and younger rocks are on the top. It's like a geological layer cake, where each layer represents a different time period. Certain fossils, called index fossils, are especially useful for dating these rocks. These are fossils of organisms that lived for relatively short periods, but were found all over the world. When you find a trilobite fossil, for example, you know the rock is between 250 and 540 million years old. Places like the Grand Canyon are like walking through a library of Earth's history. As you hike down, you're literally going backwards in time. The rocks at the bottom are nearly 2 billion years old. Isn't that cool? Now, scientists can correlate rock layers with different parts of the world using fossils. If the same fossil species appears in rocks from different continents, they know these rocks formed at about the same time. This gives us relative dating. We know which fossils are older or younger than others. Combining this with other techniques, this gives us relative dating. We know which fossils are older and younger than others. Combined with other techniques that give us absolute ages, we can build a detailed timeline of life here on Earth. The fossil record provides some of the strongest evidence for evolution. When we arrange fossils in chronological order, we can actually watch evolution happen over millions of years. Take horses, for example. The fossil record shows a clear progression from small, multi-toed forest animals to the large, single-toed grass eaters we know today. Each step in this evolution is actually preserved in fossils. Even more dramatic is whale evolution. That's right, whales. Fossils show the step-by-step transition from four-legged land mammals to fully aquatic whales. We can see legs gradually becoming flippers and nostrils moving to the top of the head to become blowholes. That's right, whales used to be on land, but now they're in the water. Isn't that crazy? Now, transitional fossils are especially exciting because they show organisms with characteristics of two different groups. Archaeopteryx has features of both reptiles and birds. Tiktaalik shows the transition from fish to land animals. The fossil record also reveals mass extinction events, times where huge numbers of species died out rapidly. The most famous is the extinction that killed the dinosaurs about 66 million years ago, but there have been at least 5 major mass extinctions here on Earth. But extinctions also create opportunities. After each mass extinction, we see adaptive radiation, the rapid revolution of new species to fill empty ecological niches. Mammals diversified rapidly after the dinosaurs went extinct. Some fossil discoveries have completely changed our understanding of life's history. Sue, the most complete T-Rex skeleton ever found, taught us that these predators were even more massive than we originally thought. Lucy, a 3.2 million year old early human ancestor, helped us understand how humans evolved from earlier primates. Her skeleton shows she could walk upright, but she still had many ape-like features. The Burgess Shale in Canada preserved an entire ecosystem from 500 million years ago, showing us the incredible diversity of early complex life during the Cambrian explosion. But evolution doesn't always mean dramatic change. Living fossils are species that have remained virtually unchanged for millions of years. Coelacanths, horseshoe crabs, and ginkgo trees look almost identical to their ancient fossil relatives. New fossil discoveries happen all the time. Just in recent years, we found feathered dinosaurs in China, ancient human species in caves, and complete ecosystems preserved in amber. Modern technology is revolutionizing paleontology. CT scans let us see inside fossils without actually damaging them, and 3D modeling helps us understand how ancient creatures moved and lived. And with the rise of AI, who knows what's next? The fossil record is amazing, but it's not complete. There are still gaps, some because fossilization is rare, others because the right rocks haven't been found yet or have been destroyed by geological processes. Soft-bodied organisms are especially underrepresented because they rarely fossilize. We're missing most of the microbial life that dominated Earth's earlier history. But scientists are constantly developing new techniques and finding new fossil sites. Molecular paleontology can sometimes extract ancient proteins from fossils. New imaging techniques can even reveal hidden details. The next great fossil discovery could be made by someone like you. Many important fossils have been found by amateur collectors and students on field trips. Fossils are way more than just cool rocks. They're evidence of evolution in action, records of ancient environments, and clues to the mysteries of understanding Earth's incredible 4.6 billion year history. Who knows, maybe you'll become a paleontologist discovering new species, or a geologist reading Earth's history in rock layers. Understanding fossils helps us appreciate both life's incredible diversity and understand just how fragile it can be. Now, don't forget to subscribe for more amazing science videos, and let us know down in the comments, what's the coolest fossil you've ever seen? Thanks for journeying through deep time with Sciesmic. Want to explore more about evolution, Earth's history, and geological time? Check out our complete middle school science curriculum at Sciesmic.com, where every student can learn, grow, and achieve.